Hey there, welcome to Build 2. This is that super secret channel that it seems nobody knows about, where I go into the thing I really kind of want to do, which is nerd out on stuff and share information, especially for people who it's like, hey, this isn't clicking for me, when in reality, I think things can be broken down to be a pretty simple, easy to understand topic, provided it's done in the right way. So that's kind of my passion. The whole reason I make videos is to give my unique take on stuff that I think anybody can understand. So here's what we're doing. I'm going to talk about solar. We're going to talk about energy storage in general. I think whether you're looking at doing solar battery, whether it's a household thing or a vehicle thing or a trailer thing, there's probably something in here for you that you could benefit from. So I'm just gonna, I've written down a bunch of stuff to cover. This is probably gonna go a little bit. Stick around. Hopefully you find something useful. So the video, if you haven't seen it, the bigger video on the bigger channel, we'll see how well it does, was on turning this trailer into this mobile solar energy storage unit, I guess, if you want to call it. And man, I learned a ton. It would seem like, okay, you're taking solar energy and storing it in batteries and then reusing it. What's the big deal? There were lots of little bits in there, and then that I didn't know. And then, of course, when you actually do something, you go from that theory of what you think it's going to be like to what it actually turns out to be like. That's a big transition that I've noticed. I think I understand something until I actually do it. And then it's like, oh man, there's so much more here than I expected. So we're going to dive into this. I'm going to, for those of you that just want to know wiring and stuff like that, towards the end of the video, I'm going to grab the camera and start pointing out all the little things on the install. Probably take 5 minutes doing that. But let's talk about solar for a second. I don't know about you, but living in a neighborhood like I do and being a homeowner, I occasionally, every couple of years, have some solar company come out and say, hey, we've done an evaluation on your house and we think you could blah, blah, blah to install solar panels. And they usually give you a few different options, but one of those is, hey, we're the company gonna pay for the upfront cost. And they figured out with the power company that, okay, your power bill is now going to be level loaded. Like you're going to pay, basically you pay them some reduced power bill, but then they're getting a bunch of the savings. So they upfront the cost, and then they own the panels, and you just pay them whatever the difference is. Of course, they take a cut for themselves. You can also, all right, I'm going to pay up front some chunk up front. It's all a financial game of, do you pay now and have the present value of the interest, or do I pay later and not have to have any upfront costs? But basically they're just saying, we're going to install panels on your house and you get some solar energy and you can save a little bit, just a little bit of savings on your bill. Unless you want to pay, if you want to own the things up front, then you can have all the savings, but then you're out that upfront cost. Long story short, the panels that they are installing, because they're going to connect to the grid, the panels are putting out DC power, which is just flatline, right? If you're looking at an oscilloscope, or it's just like battery power, but it's up at like 40, 50, 60 volts a panel. And to connect that to the grid, they've got to have a little inverter that takes that DC signal and uses solid state, uses some transistors in there, and goes up, down, up, down, up, down, up, down. And typically that's a grid tie inverter is connected to the grid, whatever the power is in your area, and it says, oh, what's the up down rate? Oh, it's right at 60 hertz or 59.9, whatever it is, and right now we're at a peak, so here we go. And it gets on that little roller coaster of up down voltage, and it matches it so that it doesn't screw up the power system, and it can start taking the DC power from the solar panels and putting it to the street and making your meter run backwards. And then as the sun goes down and you come home and you're cooking dinner, now you're using the grid like you used to, but the net, you feeding the grid and then using the grid, hopefully works out to zero over the entire year. But when the grid goes down, if you have a transformer go in your neighborhood and your power, or some storm, your power's out, when those little grid tie inverters that are on the miniature ones, they put them on each panel on your roof, And when they don't see a signal from the grid, they go, I'm done. But that is the reason I bring this up, is those panels with those inverters on each one, from my understanding, is the cheapest way to do solar. And so when you're trying to get this financial justification of solar panels, they're trying to have the least amount of expenditure up front with the maximum amount of payback. So having a panel with a tiny little inverter right on it that just goes straight to the grid, and it only works when the grid is on, no batteries, no chargers to charge those batteries. That's the minimum cost with the maximum dollars saved. And that's how, in combination with some kind of rebate or tax break, I can actually save money by switching to solar on my house. As soon as you want to start having emergency power or something when the sun isn't up and the grid isn't there, you got to have batteries, and that increases the cost quite a bit. That's where you get into a Tesla Powerwall with the batteries and the solar, where now the solar can actually, you have to have a charger that can charge those batteries. You can just think of a standard car battery charger, except these are likely going to be higher voltage, but still, you've got a charger that can go from the solar panels to charging the batteries. And then if you're in a house, most of the appliances are AC. They've got that up-down power signal to run, and you can't get that out of a battery without inverting it with an inverter. So as soon as you want to be off-grid, or when the power goes out, you can still do stuff. Generally, you've got to have batteries that are storing that. They can store the DC power from the solar panels and then invert it to come back out. So you've just added a bunch more cost by doing that. And it's a lot harder to justify the expenditure and payback, and if that's your goal, is to actually save some money off the power. So basically, my trailer, the system that I did, is like having a miniature Tesla Powerwall. It's like I think I said in the video, it's 38%. So a little more than a third of a Tesla Powerwall is battery capacity. And then their recommended solar setup that you would have with it, I'm probably like a quarter of that. So maybe I'm a little light on the solar panels if I wanted to match the recommended batteries and solar from that Tesla setup. The difference is I'm not connected to the grid to be able to feed anything back for my excess power. The downside being, if I'm not using the solar from my panels, they just sit there, and I'm not benefiting from that excess power. That if I'm not turning on the air conditioning, or whatever it would take, the microwave, to be able to use all of the power that I've got, it's just sitting there. But I'm not cycling the batteries and wearing them out either. So which one do you want? I'm not connected to the grid, but I can plug into the grid and charge the batteries. I believe my setup is capable of feeding back into the grid if I wanted to, but I'm not interested in doing that. So something you need to know about solar panels when you're sizing your system for whatever you want to do. Solar panels rarely put out the actual rating of what they're rated for. Solar panels are rated for, okay, I'm at the equator, the sun is directly overhead, and the peak of the day, this thing is capable of this many watts. So my solar panels, as I said, are rated for 1,000 watts. The most I've ever seen when I first installed them, I saw a momentary like 900 and so. I actually did see over 900 watts coming into them, which at like 45th parallel, as far north as we are, I was kind of shocked to see that. And the panels aren't tilted towards the sun at all. They're just sitting there horizontally. But I did see it regularly over 800 watts, and then it's more common to see it between, around 700 watts at the peak of the summer. So when you were looking at watts and okay, I've got a 1,000-watt microwave that I want to be able to run, I'll get a 1,000-watt solar panel, and it's like, no. There are losses everywhere. So you've got to take that into consideration when you're deciding how much you want. I probably could have gotten 1,200 watts of panels on my roof of the trailer, but I make educational videos. I wanted the math to be really straightforward. So it's like, all right, let's just round it off at 1,000 watts, and that'll be really easy for you, the viewer, to get a general idea, rules of thumb. In fact, we're going to get into that here in a minute. So my 1,000 watts of solar panels here, what was it? mid-August when I got them installed and had them charging everything up, I was able to get 5,000 watt hours a day. In the video, I called them tokens because this whole watts and hours and units, people can easily get confused by that. So like, okay, if a watt hour is a thing, let's just call it a token. And so, yeah, with 1,000 tokens an hour is what the rating is. It's like, all right, if it's able to put out 1,000 and I've got 8 hours in a day, then I should get 8,000. It's like, no, because solar panels really care where the sun is in the sky and what time of day it is. So between 10 o'clock in the morning and 2 o'clock in the afternoon are those just peak hours. And you go read up on solar panels and like, well, what if I have a tree blocking the way or a roof? And they're basically saying, look, if you can get where your solar panels are not shaded from 10 to 2, you're getting the lion's share of the benefit from your panels. And it's certainly the case where I'm at. I start seeing, 9 o'clock maybe, I start getting something that's completely unblocked by 10, and then it doesn't get blocked again until like 4 o'clock in the afternoon. So with that, my 1,000 watt panels, we can just go times 5, okay? So, or 1,000 tokens an hour, how many tokens in a day? Times 5. Just consider it 5 hours. It isn't 5 hours, it never hits 1,000 watts, but I got more than 5 hours of daylight. So consider that the daylight starts out really low power output, peaks out in the middle of the day, and then that power output is dropping off towards the end of the day. Summertime, take the wattage, 1,000 watts, times 5, 5,000 watt hours is what I was able to get. Now, the rule of thumb, as I look online, they say take the power rating times 4. So that'll give you a nice conservative estimate, and it won't just be the peak of the summer when you happen to have really good weather. That probably for the entire month of June, July, August, you can take your solar panel rating times 4, and that will tell you the watt hours that you're going to get in a given day. And that probably also, they're compensating for the fact that they're going to have a little inverter, that micro grid tie inverter on each panel has some losses associated with it. So that's probably where that, okay, I could multiply it times 5, but times 4 gives me a more realistic output. But in the winter, instead of times 4 or 5, it's going to be times 2. So I've had people try to tell me, no, solar panels work fine when it's cloudy because it's mostly UV and UV goes through the cloud. You can talk theory all you want. Sorry, the data doesn't lie. Even the websites that are pro-solar, you go out there and they say, yeah, whatever you're getting in summer, you can count on about half. One of them said 40 to 60%. Another one just said, you know what, just cut it off right at 50% on average of what you were getting in the summer months is what you're going to get in the winter months. And if you want to know on a yearly basis, take your wattage times 3. And that's what you'll be able to get. And yeah, with again, the benefit of grid tie inverters, whether they're on the panels or one big one, that every bit of power that your solar panels are making, you're either using in your home or it's going right to the grid. So if you're trying to do those calculations on, okay, how much do I pay for kilowatt hours? How much can I save? Those are really easy numbers to calculate. So you could look at your house and say, all right, it's household solar installations are typically starting at 3,000 to 4,000 watt panels and going up to 10,000 watt grids of panels. You can do your numbers from there. But yeah, clouds suck. Even during the nice bright days that I had, it's like, wow, I'm getting 800 watts, and then you get a cloud coming in and it would just drop to like 3. I mean, it was less than half for me when a cloud would come by and the cloud goes out of the way, boop, and the output, I'm just sitting here watching it. I'm either watching it on my phone or I can watch it on the touch display, and it's just going up and down and up and down. So yeah, clouds really freaking matter when they get in between the sun and your panels. They make a big difference. We talked about efficiency losses already, not just from your inverter. So when my inverter is taking from the batteries and powering the air conditioning, there's couple hundred watts of losses there the inverters will claim a much higher efficiency. Inverters, generators, any of these things that are making AC power, they'll claim a higher efficiency. It's usually at a lower draw level. So if you're running something, what would be something with less wattage? I mean, certainly I leave the inverter on this thing. Just having the inverter on draws like 6 watts of power, but I've got a big enough solar array to make up for it. So when we're charging phones and things, yeah, we're plugged into the AC outlets that are throughout the trailer here. We're just leaving them on all the time because, again, there's enough solar panel to be able to make that up, that maybe it drops off. Just the inverter being on might drop the battery down to 98% overnight, and then as soon as the sun hits it, it boop, just charges it right back almost instantly. And there are losses from the solar charge controller that is taking the solar power and charging the battery with it. That thing gets warm too. You put your hand on it, it's like, wow, this thing's getting hot. It's like, yeah, that heat that's coming off of there are efficiency losses. So there's another one of those places where that you can't just take your 1,000 watts, whatever the rating is, times some number and figure that it's all going to work out maximally every day. One cool thing about going with Victron, I didn't realize this when I first started working with them. They said, yeah, if you want CAD models for stuff to see if it fits, their CAD models are right on their website. You don't have to make an account, or I don't think you do, but you just go right on the Victron website and you can select whatever component that they sell and get a CAD model of it. Must be a step file, and bring that right into the CAD. It had color on it and everything. So those models that you saw in the video of the Victron Multi-Plus and the solar charge controller, I just downloaded those models. I didn't have to make them. Whereas the batteries, I had to go sit there old school, take measurements, model it up, and I actually took pictures and threw the decals on there in Fusion 360. So either way, I got there, but it was really handy working. So there's a reason to work with Victron if you needed one, was that if you're trying to make stuff fit, they are gracious enough to give you CAD models to work with. It's really handy. Let's talk about wiring for a second. Wire is expensive when you're working with a system like this, and you don't want to skimp on it. In any electrical system, it is really, really important. It's like the first step. You figure out, all right, what am I going to do with this power? How much am I going to draw? How many amps am I going to be pulling from the power source? And then what wire size am I going to need? And then when you go to the wire chart, it'll say, well, if you're only going to go less than a couple meters, then you can use this wire size. But if you're going to go from one end of your trailer to the other, then you need to step up to the next bigger wire size. And well, why is that? Well, because every wire is a little bit of a resistor. And if you're trying to pull, what happens to resistors when you're pulling current through them? They get hot. And if it's getting hot, like I said with the charge controller, if you're feeling heat, that's lost energy. That's efficiency that you're missing out on. So if you want to be able to benefit maximally from your panels, from your batteries, everything that you're doing, if you don't want a bunch of losses in your system, you want to make sure, well, if you don't want to start a fire, you want the right wire size. If you're nervous about efficiency, then yeah, go the next size up kind of a thing, and try to keep things close together, where you're not having to go from one end of the trailer or one end of whatever installation to the other, running electricity down those wires. So I used the Blue Sea wire chart. It's very easy to use. I'll put a link in it or show it on the screen here, that you can just pick, okay, what's the current that I need and what distances am I going? And it'll tell you, sometimes you've got two, like, well, you could get away with this gauge, but it's probably better to go to this gauge. Also, if you look at, like, if you get on whatever, Amazon, online, looking for the cheapest price on wire, you're going to say, oh, this stuff is really cheap. And chances are, if you found really cheap wire, it's not copper wire, it's aluminum. And aluminum is not as conductive as copper. So make sure that Blue Sea chart is for copper. If you go to aluminum, it's going to tell you need a much bigger size to be able to get the same current rating. So all of the wire that I used is tinned copper wire. So I've got the copper for the conductivity and the flexibility of it. And then when it's tinned, it's less likely to corrode. I mentioned I'm not that far from the coast, and we go to the coast pretty often enough with this thing, get condensation on the inside of the walls, and it's like, all right, I'm gonna do tinned copper on everything and do a nice crimp connection, and then do a sealed piece of shrink tubing that's got adhesive on the inside. That's what is done for boats. I think that might be legally required for boats. And the installer, the shop that I was working with, that's what they do on all of their stuff. You don't have to, but realize if you're going to go with this, like my dad has been playing around with battery storage at their house because the power goes out frequently, and so he has gotten a bunch of batteries there, and he's doing all the things that you're not supposed to do. He's like, oh, the cheapest wire he could find, like he got some jumper cables from Bimart, and it's like, oh, these are cheap, I'll use this wire. And it's like, yeah, those are copper clad aluminum. So it's aluminum wire that they've coated with copper. And I'm not sure if they're doing that for the conductivity of the copper on the surface of the wire, or just to fool people into thinking they're getting copper wire, but it's a lot cheaper than pure copper wire, which is cheaper than the tinned copper wire. So it's one of these things like, yeah, it costs a little bit more to do the tinned copper up front, but then every time you use your system, you're saving some energy on it. Will it work with the, say, my dad's gotten the lead acid batteries and using copper coated aluminum wire. Does it work? Yes. Could you be getting more time out of it as they're, when the power goes out, if they were using more efficient stuff? Yes, they yes, they would. So that's what I did. There you go. Now you know, do with that knowledge what you will. How much could I save? Because in the back of my mind, it's been, oh, hey, I'm putting 1,000 watts of solar right next to my house. Could I just plug into this thing and start powering my house with it? Well, one, yes, I could. The biggest thing to be concerned about is back to that grid tie thing. Okay, I don't want to just take any old inverter that you buy at the hardware store and somehow do a male plug and plug it into the house, because the odds of it lining up and syncing up perfectly with what the grid is doing are near zero. So that's where a special inverter called a grid tie inverter that's able to look at the grid and match up with it and run power both directions. I wouldn't doubt that the Victron charger inverter, the Multi-Plus that I got, is capable of that. I don't want to mess with it. If I've heard the stories of people doing stuff like that without talking to their power company, and the power company sees that all of a sudden their meter is trying to run backwards a couple of times, and they come knock on your door and go, hey, what are you doing that you're not telling us about? But I went ahead and ran the numbers of like, okay, how much could I save? I said in the video, this was basically like a $6,000 install, the way that I did it. How much could I save? How long would it take to pay that back? Let's see, look at my numbers here. That 1 kilowatt or 1,000 watts, this Smart Solar for Oregon was saying that for my area, you can basically take your rating and go times to get your watt hours for the entire year. Their example was 6,000 watt, 6 kilowatt set of panels on your house, that you could figure an annual 6,800 kilowatt hours to get that total watt hours annually is a little over 1,000. If you wanted to go take the your kilowatts to kilowatt hours for an entire year in this northern, northwest Oregon, they said 100 miles south it would be right at like 7,000 kilowatt hours a year, whatever. I'm just speaking in rough numbers. So with my 1,000 watt panels, if I could use everything that they're putting out every day, I go times 1,000, so that says 1,000 kilowatt hours per year. It's probably more like 1,100 kilowatt hours per year. Times, so my power bill, I haven't looked at the power bill. I was just Googling online. It's like 14 cents a kilowatt hour. So 14 cents, okay, times my roughly 1,000 kilowatt hours a year comes out to 140 bucks a year of my $6,000 investment. If I was using all the power that the panels could make, it'd be 140. Now I was conservative, so maybe it's 150 bucks a year. So if I divide the $6,000 by this 140, we're talking 40 years for it to be able to pay back. And that's after the solar panels have expired. they're good for 25 years. So this investing in the batteries and everything doesn't pay back. This is where and I've seen this from other folks online talking about, hey, I did this solar system and here are the monies. It's a year later or it's 3 years later and here's the payback. And they're always using the tax incentive, this tax rebate, to calculate into the numbers. And that's fine. But without that rebate, to me, it doesn't look like the numbers would pencil. If you're looking at this solar panels from purely a financial standpoint of does this make sense financially, the reason that you have the rebate from the federal government is to make it pencil, because without that, it would not. Critics will say that, well, then basically what you're doing is your neighbors are helping finance your solar panels. And I 100% agree. The video that I saw, someone was saying, no, it's not at all, because it's a tax rebate. It's not actually making everybody pay for it. It's like, no, that's my perspective is if you were going to be paying, if you're making $80,000 a year and you're normally paying $20,000 in taxes, and then the government says, oh, you don't have to pay 10,000 of that now because you did solar panels, that money's coming from somewhere and it's coming out of the fund that you would normally have been paying into. So yes, everyone else around you is paying taxes to pay for that rebate from the federal government. Be that as it may, I'm not judging. I'm just saying those are the facts, that the federal government is giving these rebates so that or these tax incentives so that the solar panels pencil out, and then the homeowners can, it's like, oh, okay, this makes sense for me financially, just barely, just enough incentive for this to pay back. From a carbon footprint kind of a thing is like, well, I care most about climate change, and so it doesn't matter the amount of money that we're spending on it because we need to save the planet. I will take that as an argument that this is the motivation for doing it, that we're trying to reduce carbon emissions. That I can get behind because that's legit with the numbers. I went looking for, like, if you want to fully understand an issue, don't get all your information from one source. When I want to really know what the truth is, here's a little cheat code for life hack, that whatever I'm being told by the person I talk to, I go try to find, I get on Google and try to find the exact opposite. So most of the content that I looked up on solar panels was solar panels are great and they always pay back, and yes, go get solar panels, everybody should have them. And so I went Googling solar panels are bad for the environment, solar panels, bad carbon footprint. I just went looking for the most negative stuff I could find, and the truth will be somewhere in between. So when I went looking for the most negative information I could find on solar panels, they still said, yeah, that initial carbon footprint from the because let's not kid ourselves either, manufacturing a solar panel takes hydrocarbons, emits CO2 to do that, unless you're like have a really special power source right next to the factory. There is a carbon footprint associated, right down to the truck that delivered these things to my house was burning fuel to deliver them. So until I started actually generating power from them, it was all carbon. And then what I found through my research, even the most negative assessment, said that at the 5-year mark, they have paid back that carbon footprint. Varies widely with the area and what your normal power source would be. But at that 5-year point, they had paid it back, and then it was all green after that. Okay, great. According to that, solar panels are a win for the environment, for green energy and renewable energy. So if that's your motivation, I care more about climate change than I do about accounts balance out just perfectly. Good on you. Trying to say that they do pencil, the tax incentive, it's all good, it just comes out of thin air. It's like, no, I disagree with that assessment. My setup, there's no way it's going to pay back, but it is an emergency mobile power station anytime I want. This thing is not plugged in. It's parked next to my house, but it's not plugged in at all. I've had family come stay from out of town, and it's like, hey, go use the trailer, plug in, turn the lights on. Doesn't matter if they were to turn on the air conditioning and run the batteries dead. The next day, if in the summer, it's going to fully charge the batteries by the end of the day. That's freaking magic. That's worth some amount of money to me, that I don't need it to pencil financially if I'm getting this incredible, just like I said, border on magical use of energy sitting right next to my house. The whole grid could blow up and I can come out and turn on the lights, charge my phone, whatever I want to do. That is pretty cool. Again, are you looking for a financial thing? How much is emergency power worth to you that you don't have to fire up a generator and to be able to get that energy and annoy your neighbors with the noise? So just things to think about as you're considering what type of installation you might be interested in. And obviously, small systems like this are not recouping the investment very fast, hence why you want to go with these 4 kilowatt, 6 kilowatt, 8 kilowatt, even a 10 kilowatt solar install, because you've got these, just talking to a contractor, talking to the city, getting set up for that, paying somebody to come out to your house and doing connections to the grid. That all has a minimum cost associated with it. So it just doesn't make sense to have those people come out and hook up a 1,000 watt setup, solar setup to your house. You've got to have this 4 kilowatt, 8 kilowatt. The bigger that is, that initial cost of having somebody come out is now getting distributed over a much greater payback. Oh yeah, another great thing that I learned that was it was actually on Brilliant when I was going through and this isn't a sponsored video by Brilliant. I'm just legitimately impressed with their solar energy, solar power content. They talked about solar energy versus other types of energy, and they said every other energy source that's out there has some kind of moving parts. I don't care if it's nuclear, if it's natural gas, if it's wind, if it's hydro. You're spinning something that's got bearings in it that is eventually going to wear out. And so there's regular maintenance of changing out those parts that are wearing, versus solar panels. The only thing that's moving is electrons. And that I was reading that up in Brilliant. It was like, oh, that makes complete sense. Now, solar panels do wear out eventually. They typically say it's like a 25-year life, and then they're running at 80-something% at that point, which is still well worth it in my mind. But because the electron's the only thing that's moving, there's very little, there's no maintenance to do other than, okay, I'm going to spray these things off every once in a while if they've built up some dirt on them, because that'll help with the efficiency. The one negative of the solar panels, once everything's said and done, regardless of where you're at on the green energy thing, is that when you're done, you got to take them somewhere, and they're going into a landfill. So that's the one, like, anti-solar, like, solar panels aren't that great, you got to throw them away. It's like, yeah, okay, a lot of things you got to throw away. I mean, engines, turbines, whatever, stuff wears out and it has to get thrown away, and that is the one negative of solar panels. Eventually, it makes sense to replace them with new ones, and you got to throw away the old stuff. So I've got buddies with trailers that have been interested in having a solar panel, and they don't want to spend $6,000 on a system. So they're like, I'm out. And like, yeah, okay, what could they do if they didn't want to spend a bunch of money on a giant system? Well, you got to have a panel, and they've already got a battery, right? So can I just take a panel and connect it to a battery? You can, but then those solar panels, the voltage, if you were to connect to the voltage, they're doing near nothing at night, and then peak of the day from a 100-watt solar panel, you're going to see in excess of 20 volts. And you don't want to be pumping 20 volts into a 12-volt battery for very long. If the battery is low initially, like if it was end of the world kind of thing and I had a dead 12 volt battery that I could go connect a solar panel to and just sit there and monitor the voltage and disconnect the solar panel once the battery got all the way up. Open circuit voltage on the solar panel might be 20 volts, but as soon as I connect it to this deep cycle 12 volt battery that's like down at 10 volts, it's going to pull that solar panel output down to 10 and a half, 11 or something. You'll be able to watch that voltage creep up until it eventually gets to higher than you want your battery to charge to. If you were disconnecting it at that point, then hey, you are doing the job of a battery management system, a BMS. So you want to have something to manage your batteries so that when they get up to that, as they're starting to top off, it'll change the profile of how it's charging it. You know, it's giving it everything it can when the battery is low, and then the closer it gets to being peaked out, it's going to say, okay, now I'm only going to give you this much current and only going to give you this much voltage until it gets up to its maximum charge and says, no more, even if you had something hooked up to it. But then those BMSs are generally not designed to take 20 volts or 40 volts or whatever is coming off of your solar panels. So that's where you want a charge controller. You see the giant blue Victron charge controller that I've got. And that will take the 20 or 40 or 100 and something, depending on how you've got your solar panels wired. That'll drop your voltage down to much closer to the, depending on the chemistry of the battery that you're using. If it's lead acid batteries, is going to be 13 something, and then the lithium batteries are going to be 14 something. Don't quote me on that. Go look at your own battery manufacturer and what their recommendations are. And they're just going to supply a little bit over that. If they're doing their job, when things get topped off, they'll basically shut off and they're not sitting there fighting each other the whole time. So I've tried to get away with having one or the other in the past, and bad things happen. I've got some lithium batteries I did for a project for my son with the little go-kart he was able to drive around, and I just followed what somebody else was doing on the internet of having this charge controller connected directly to the batteries, and I reasoned that that ought to be enough. It was not. And I can show you, I'll take a quick clip of the batteries. They swell up, it's dangerous. So you want your BMS protecting your batteries, and you want your charge controller helping control what the solar panels are doing. And if you want the most efficiency that you can get, then you want your MPPT, max power point tracking, I believe that stands for, so that it's sitting there constantly challenging the solar panels, like how much voltage and current can I get out of you. I'll keep drawing current and see how much the voltage is dropping, and it's looking for this peak efficiency that it can be able to charge the batteries with to be able to get the most out of your solar panels. That is my understanding of how those MPPT controllers work. So my buddies that want to do a minimal setup is to have, 1 or 200 watts or something on their trailer just to keep their battery topped off for the usage of lights and running things off of propane. You want to have a battery management system protecting your battery, and then a charge controller regulating what's coming from the solar panel. Connect those things up, great. Before we got this trailer, we rented a trailer that had just a single 100 watt, maybe it was a 200 watt solar panel. It was pretty sizable. I think it might have been just a 100 watt solar panel, and then it had a couple of sizable batteries. I don't know if they were lithium or not. I wish I had paid closer attention. And then it had a charge controller and I think it had a really small inverter that was connected to just one of the AC outlets in the trailer. And we took that thing at a place with no plugins and had 3 nights there, and we were super careful with any of the power that we were using. And we could see that the open circuit voltage on the battery at night when there was no sun or anything was dropping like 0.1 volt a day kind of thing. So it was actually doing really well. We weren't quite keeping up with that panel with just partial sun, but it was enough. So for those of you who are just looking like, hey, I just want to be able to go off grid and still turn on my LED lighting inside of my trailer at night, run the water pump to be able to take a shower and keep the propane powered fridge running. Yeah, you can probably do it with a 1 or 200 watt panel as long as you get enough sun and a couple of decent sized batteries and you can get that to work, and it'll work fine. One quick mention before I go into the hardware side of things is the amount of hydrocarbons that we used on that trip. So I may make, depending on the popularity of this video, I may go make another video on the big channel about towing and electric vehicles, because I mean, I love this installation. Please don't get the impression that I'm like anti-green energy. I am totally 100% in on renewable energy sources. I've been reluctant to put solar panels on my house for a number of reasons. One of them being that the roof is wearing out, but the roof is pretty much at the end of its life. And so I'm seriously considering, after we replace the roof, installing a full-on, I don't know how many 1,000-watt setup we would do, and I'd have to decide if I was going to invest in batteries or not. Just for cost effectiveness, I'd probably do the microinverters on each panel and just maximize the output, because that's really what I would be about. For emergency power, I got this thing, you know, if I really need to go cook something, I've got propane tanks and things I can make it work. I would love to transition over to complete solar and electric, but I've got 3 old vehicles. I haven't bought a new vehicle in over 20 years because I'm a handy guy, and I have been into the transmission and the engine and stuff on my Bronco. All of my vehicles, I've done some kind of serious work on them, and that's how I save money, is by driving older vehicles and not having to pay that upfront cost of something expensive. Electric cars, spending that money, that I'm not in the market for one of those. But if I was, okay, would you do an electric truck and go tow, get a Rivian, get a Tesla, whatever, and go do this same trip on complete electricity? I don't think I would, from what I'm seeing. I took footage every time I topped off the Broncos. It was a almost 400-mile trip, and with the 25-gallon tank in the Bronco, I can get close to like 15 miles per gallon when I'm driving without a trailer, but it drops to 8 or less when we are towing a trailer. And you go research towing with an electric truck, and people that actually try it are blown away by how much their range drops. And guess what? My mileage goes roughly in half on my Bronco when I'm pulling a trailer. Your range will go roughly in half when using an electric truck. Were there supercharging stations, whatever Tesla calls them, up and down the I-5 corridor where I went on this trip? Yes, there were plenty of those that I could have stopped and charged. It was a triple-digit day. So on a good day, I would have to park for like 45 minutes to get a complete charge back on my Bronco if it was electric. So I'd have to park a while to do it. Most of those stations are not set up to take a trailer, so what I'm researching is that I would have to go to the parking lot there, unhitch my electric truck from the trailer so that I could back in or nose in without a trailer. I noticed I saw a Rivian that was getting charged on the nose end of it. It's like, oh, okay, well, at least you could pull in, but I got this 25-foot trailer hanging off the back end where nobody can access it. So still need to take the trailer off, pull in, charge for 45 minutes, pull back out, hitch back up. I mean, you're talking about a 2-hour, at least an hour and a half to be able to unhitch, charge, rehitch, and get back on the road. And then this particular day that we went, it was after we got past Eugene, it was over 100 degrees everywhere we went. So we saw 112. I think my wife said she saw 116 on the dash. And yeah, in Grants Pass, the forecast was 102. So it was really hot, and batteries don't like that. When you get up to super hot temperatures, you'll still be able to charge, but it's going to like kick on your air conditioning and to chill the batteries. And it will take, from what I'm reading online, people that are going to charge on super hot days, that it takes longer to charge. So, not saying we couldn't have made it down there with a Rivian or a Tesla truck or something hauling this trailer, but it probably would have taken a lot longer than just pulling through a normal gas station, gluck, 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 fill me back up, and we're back on the road in literally 5 minutes. That is way more appealing than this longer trip of having to plan 1.5 to 2 hour breaks at multiple places on the way. And we did one last, we didn't have to fill up twice before we got there because it was less than 400 miles. I could have gotten there with an empty tank in the Bronco, and what good would that have been? So we filled up in Grants Pass. I was told, hey, pay Oregon prices for gas before you get into California. That's what we did. So we ended up just topping off the tank a handful of times, which you can also do with the electric charging. But I'm seeing in the news now, just as of like yesterday, that the Tesla semi truck is like doing, what did they say, 500 or 600 kilometers, that they were doing a Pepsi or Coke or whatever it was, a beverage delivery of like an 80,000 pound load. So, you know, no, they're not skimping on the load of what they're asking it to pull, and that they're actually getting some really good range out of the thing. So, and all I can think is, I haven't looked into it. They must, man, where are they cramming those batteries? Are they adding batteries into the trailer? Have they just completely filled? Should look up and see what the kilowatt hour battery is for one of those Tesla semis. It must be massive, and then they've got a way to be able to recharge it really quickly. So if they've been able to figure it out, that's awesome, because I really would love to see everything being electric. For most people, if you look at the numbers, an electric vehicle makes a lot of sense. I think the average commute in America was like 20 or 30 miles a day. There isn't an electric vehicle out there that can't handle that easily. You'd charge the thing once a week and you'd be fine. So I think for most people, an electric vehicle makes a lot of sense. We do have occasional drive. It's 400 miles to my sister's house, and I can do that on one tank in my Camry. We can make it all the way there on one tank of gas if we top off before we leave. Now, I don't care stopping halfway to charge up on a car if you plan lunch around that. So, you know, it's not the end of the world if you can't do it. But we're in this transition period with battery technology and things, and I am looking forward to when we can do everything with electric. We're just not. It just doesn't seem like we're quite there just yet. All right, let's take a look at the installation for those of you that want to see that. Okay, you saw the whole thing. Oh, I should have my wide angle lens on this thing. Oh, we'll manage. You saw the whole installation. We've got, these are the wires here coming down from the combiner box up on the roof, and they're going right into a breaker. So yeah, you gotta have breakers. You gotta have fuses in case something nothing went wrong, thankfully. But if I hadn't done a solid enough install and something tried to fall when we were going over a bump, and you get a positive straight to the frame or positive negative together, you want a fuse to blow and not have a big old fire and shower of sparks. So got to have breakers, and where this is really nice that I can just flip this lever and disconnect the panels. I've disconnected the batteries. Same thing down here. We've got a battery disconnect switch right here. I've actually disconnected those I was going to do some maintenance on it. I don't remember what it was for. And it was like, hey, how come this thing still has power? It's like, oh, because it's sunny outside and this thing is still on. So, all right, power comes in from the panels, goes through this. Note the size of that wire that goes into this nice wire cable management there, and goes right into the bottom of my solar charge controller, MPPT, from Victron. And so this is like, what is the voltage on this? It's like 40 volts, 44 volts coming in. And then these are the batteries going out. And just look at the size comparison of these little guys on the right versus these ginormous suckers on the left. Why is that? Well, I kind of think of current and voltage as this teeter-totter thing. So if you want with the same amount of power, let's say you've got a 1,000-watt teeter-totter, and you're going to put high voltage on one side, then okay, then if if it's going to balance out, okay, high voltage, then my amps are down. And if I want a lot of amps, I can have them, but my voltage has to drop because your volts times amps equals your power. So that's what this solar charge controller is doing, is taking this high voltage, low amperage, and it's turning it into low voltage. So, 14 volts for charging these batteries. And then the amps go way up, and that's why this thing has to be rated for 85 amps, because you take the 1,000 watts of solar times the whatever the voltage, and it works out to like 83 amps that this thing has to be able to handle. And so that's tiny wires, high voltage, like think of the high voltage transmission lines that are going across the country. That's why they do that. It goes super high voltage. You can use much smaller conductors. As soon as you drop down to a 12 volt, the lower the voltage, now you got to have big fat wires on there. Hence why when we go down to our batteries, look at these just massive, massive wires. So the installer that I was working with was trying to talk me into a 48 volt system, because that's pretty much all he does. He's like, yeah, the whole industry has switched over to 48 volt. And as we just said, with our little teeter-totter of volts and amps, when these are set up for a 12 volt system, if I were to go to 48 volts, boom, volts go up, amps go down to get the same amount of power. I could still be supplying this nice 3,000 watt inverter with much smaller wires. That would have saved me there. And because this guy, the solar charge controller, is not having to go from a high voltage to a low voltage, is not having to work as hard. So there's more efficiency if you just keep your voltages high. Now, if I had done that, if I had gone to 48 volt batteries like he was recommending, the rest of my system, my fridge, my lighting that's in here is 12 volt. So I would have had to add a DC to DC voltage converter to be able to take the 48 volts from the batteries. I mean, I could have taken these two batteries and put them in series at 24 volt. And I would have a DC to DC, so buck or boost. So it'd be a buck converter that would drop the 48 volts or 24 volts down to 12 volts. So that would have been another component that I probably would have just stuck on the wall here somewhere, stuck on the ceiling, or found a different spot for. And I didn't want to do that. I want to just, I want to keep this as simple as I can. So I ended up staying with the 12 volt system, but it's what drove these massive wires leading to everything. So yeah, high voltage, low amps coming into the bottom of our charge controller from basically directly from the panels, going to and these go all the way down to the bus they're basically connecting almost directly to the batteries, which have a built-in BMS inside the batteries. That's you say, hey Quint, where's your battery management system that's protecting your batteries? It's inside those. Kind of cool that it comes with them. And then, so the inverter also connects. So like I had mentioned, this Lynx distributor is basically two giant bus bars inside of there. If you look at I don't want to open it right now, but you could look at the footage that I have. I'll put that on the screen, showing you what that looks like on the inside. And so yeah, we've got these massive connections in there, so that these two wires right here, if you can see, they go right off into the wire ducting on the back, and they're running up inside of there, and they go right into the bottom of the Multiplus, which is the giant inverter. So they're going in there so that when we want to produce enough AC to run the air conditioning and the microwave at the same time, we can actually do that they're pulling just massive amps from the batteries. And then if we're wanting to charge them, if we plug into the grid, if we used a bunch of power and we're not able to get enough sunlight to charge things, or we want to charge it faster, or we just want to hey, it's been really hot and we've gotten to, I'll talk to the camera here for a sec. So let's say that we went to, in fact, we did this on our trip after, when we got pushed out of our spot at the Panther Flat there. We went right down the road and just said, you know what, we're just going to go to an RV park and plug in and charge everything up and use the AC. We said this has just been enough chaos that we want to be able to relax and have a nice comfortable stay that night. And so yeah, we plugged in and let the multi-plus, that is not just an inverter, but it's also a charge controller. We used grid power to charge up our batteries and run the AC at the same time. And it was like, oh, so that's what those massive, that's the other thing that those massive wires are there for, is being able to, when we were charging, when this thing was plugged into, the multi-plus was plugged into the grid, then it was able to send those amps now back into the batteries and charge them. Let's see. Oh yeah, so I'm running, you might have noticed that I've got smaller wires actually connecting directly to the batteries. And yes, I'm aware I'm wearing a metal watch that if I get it across the wrong place, that could be a bad thing. So I'm not going to put my hand in there for that reason. But I've got smaller wires coming off each battery because I've got these two batteries in parallel. So the voltage is the same, but I've doubled the voltage is the same, but I've doubled the capacity on them. So these are 200 amp hour batteries each, and they've got, let's see if we look down on the side. Ta-da. Held in by magnets, kind of cool. So 200 amp hour, so 12.8 volts times 200, so volts times amps is power, right? So 12.8 times 2, that's where this 2,560 watt hour number comes from, that is right on the battery. And then because there are two of them, we get to add that together, and that's where the roughly 5,000, that's where I'm getting that roughly 5,000 watt hours of capacity. So they're in parallel, so we get to add, it's now a 400, we can take 400 amp hour times the 12.8, and that's where the 5,000 and something is coming from, which, like I said, the Tesla Powerwall is 13 and a half. Tesla Powerwall is 13.5 kilowatt hours. So this worked out to 38% of a Tesla Powerwall in my little trailer. So that's kind of cool. But those smaller wires that are carrying, they're in parallel. So each wire is, I've got two positives here going from the positive of each battery and two negatives in the back. And they are coming up together into a little cheap off-the-shelf bus that I found. So smaller wires going to this, what do you want to call it, junction box or a little bus bar setup. And then from that's where they're combined, and I have these two larger of the quadruple-aught or 4-aught cables that are then feeding the rest of the system. The Lynx distributor there did not have a really clean way to just go, it's meant to get its power in from one end. And if I had done a 48 volt system where I had, or even 24 volt, if I'd had these batteries in series, that would have been much easier to be able to just connect positive and negative to these two buses that are going into the Lynx distributor, and that would have worked out great. But again, so I was paying some penalties there for sticking with my 12 volts, and one of them was having this extra connector here for this, say they're just a way to bring the batteries together in parallel and then have these two wires. So yeah, make your look at what I did and make your own decisions on what you want to do. I think that pretty much, yeah, so when you're installing, if you're doing anything with batteries like this, you really don't want to get, oh, yeah, you really don't want to get anything arcing across your batteries. I caught myself starting to do some work with my watch on. I was like, no, get that thing off, because, you know, human skin across a 12-volt battery isn't going to do anything, but metal will weld in a heartbeat, which I didn't know anything about these. And I know I'm getting my hand in there kind of close, but these fuses, MRBF, I think they were what they're called, little fuses that are right on the post of the battery. I did not know those existed before I did this project. They're not very expensive and they're really handy. There we go. Got one on each one. So right off of the battery, if anything, again, if we had some kind of tool fell and arced across a battery or arced across a wire, or a wire came loose and tried to short circuit, we've got these, I think I went with 150 amp fuses right on top of the battery. It's just going to go pow and protect the whole rest of the system. And so, yeah, we've got a switch to be able to disconnect. That's an absolute must. This, if you're used to Victron, but you haven't seen, is like, hey, how did he install this so cleanly? This plastic milled piece of plastic back here came from the shop that I was working with. That was my lifeline for questions. I'll put a link to that in the video description. It was really, really handy. When I saw what everybody else was doing online with their Victron installations, with their Links distributor and putting a switch on there, this looks way cleaner. I am really happy with how that came together, and it was that innovation of the shop that I've been working with. Like, it has the brand on there, and again, you'll I don't want to mispronounce it, but yeah, it is a really slick installation, especially for me. I mean, just look how much room I didn't have. And this was it was really nice to not have another 3 inches of stuff sticking out which is what you would normally do to connect your disconnect switch to your Links distributor. You'd have an extra bar in there, and this just links them right up, makes everything bolt right together. Really, really slick. I didn't know how nice that was going to be until I installed it. It was like, ooh, sweet. And because I am on a relatively thin wall here on the back, and there's really nothing inside of that except for each end, I opted for I just got a 1/2 inch piece of sanded plywood that I ran a bunch of screws in to be able to have a plurality of fasteners, if you will, taking all of that load, so that board is on there nice and solidly, and then I can run I don't know if it was 4 or 6 or 8 fasteners that were holding this nice little backing plate, their mounting plate, really securely, so I don't have to worry about anything moving on me. Okay, is there anything I missed? Oh, yeah. Let's just power things up real quick. Let's see what we're doing right now. So I've got 47 watts of AC load, so the inverter is running, and it's basically running this crappy studio light that I've got sitting here is pulling 47 watts. We've only got 83 watts coming off of the solar panel, even though it is almost 11:30 on a sunny day, but that's because our batteries are topped off at 100%. So that's all that we can take from our solar panels. And this is back to if this was a grid tied, if I had a grid tie inverter, we'd be getting everything the panels could give and pumping it into the grid. But because I'm not tied to the grid, I'm just tied to the batteries, the maximum it can put out, I didn't mean to do that, the maximum it can put out, let's go back to, the maximum that it can put out is whatever the batteries and whatever our usage is. So let's turn on the usage. It's getting a little bit warm in here. Let's turn on the AC. Come on. 70, 69, 68. There we go. That should kick it on. There it goes. All right, fan's blowing. It just gets the air moving. Come on, focus. And now the compressor's kicking on. Oh yeah. So we're pulling 52 amps through those big, 53 amps through those big wires. And how much solar are we getting? 500 and something. So you got to see the solar panel output is now coming up. So we're using the 500 and something watts of solar panel, and that's obviously not enough to make 1,000 watts for the AC. So we're pulling the remaining from the battery. It looks like we're 60 amps now. But let's really challenge the system. Let's see. Let's turn on the microwave for a bit. We're just going to hit it for 30 seconds. There we go. Now our AC load is 2,200 watts, 2,300, and we are pulling 211 amps from the battery. So 100 amps going through each of these freaking wires. Can you believe that? So pretty impressive. Okay, the microwave just went for 30 seconds and now it's going to shut off. But pretty impressive with this not connected to the grid installation that is pure solar power. This thing hasn't been plugged in weeks now, that we can sit here and run the AC and microwave something, getting well over 2,000 watts, and the battery's still sitting there at 99%. I mean, I could sit in here for a few hours with the air conditioning with the batteries, especially since we have the solar panels that are feeding it at the same time, and they're going to peak out and say they're going to get 700-800 watts here as the sun gets up noon, 1 o'clock, 2 o'clock. So pretty cool stuff. Obviously, I'm super excited to be able to do this and share this experience of all the things that I've learned with you. Hey, it just turned off. Oh, it's kicking back on again. Let me get out of the way. So obviously it's been really cool to do this and share this experience with you, all the things that I've learned. I have no idea how well this video, the bigger video, is going to do on the channel. I try to do the most high quality projects that I possibly can, and some of them take off like gangbusters and others don't. I don't really know what drives that. I'm just going to keep making the best content that I possibly can. If you enjoyed this and got something out of it, subscribe. Consider looking up Patreon if you want to help support these kinds of efforts. It is really, really, really appreciated. Thank you to all the patrons that have been with me this long. I can't tell you how much it means to me that you're there to support the channel. All right, I will see you in the next video.